Alright, welcome back to the channel. We are going to be rounding off the series, as we earlier promised, with a series of questions on variation. So the questions are going to span through all the 4 types of variation that we have actually discussed. And if you have not already, please go back to watch those videos, because the videos that we did on the various types of variation, because they are going to help you to understand very well all that we're going to be doing in this series of questions. As well, in these questions, we are going to explain briefly on the way you approach a question when you see them in exams, so as to give you speed and of course a degree of accuracy while you calculate. Alright, we're going to get into it, and do well to subscribe to the channel if you have not already, or because in this channel we post content that are going to help you, are relevant to science, are going to help you to ace your exams as well. The first question says, the cost of painting a square of room varies as the square of its length. Now, seeing this beginning, you already know that this is a direct variation, and according to as we talked about, we said that you should use the heuristic method. That is, analyze your parameters one by one as you see it, step by step as you're given. So it says cost. So we could say our cost will be represented by C. Now this is not necessary, but you could write that just in case, so that your marker, your examiner will not be lost. Alright, so we have C and L for cost and length. I guess those are the 2 parameters we are comparing here. So it says the cost varies, so it says varies as the square of length, meaning that it varies directly. So that notation is going to be C varies as L squared. So from here we have to introduce an equal sign. And when we put an equal sign, then the constant, it must be a constant of proportionality that allows the relationship to be valid. So we have C is equal to KL squared. So this is our equation. Alright, so we have to solve for K now. We have to solve for K. It now says the cost of painting a room of 5 meters square is 500 naira. So if the room is 5 meters square, it means that the square, it means that the room is a square, of course. So each portion is, each side of the room is 5 meters long. So our L in the first case is given to be 5 meters, and the cost is given to be 500 naira. 500 naira. So we are going to simply plug in our values to find the value of K. So we plug in our values, and we have 500 is equal to K by L squared, which is 5, of course, 5 squared. So you have K equal to 500 over 5 squared is 25. So you have K will be equal to 25, and this is 20. So we have 20. So from here, remember that after getting your K, the next thing that you must do before you do any other thing is rewrite this equation in the right format, such that your constant must appear. So you have C will now be equal to 20 L squared. So this is the actual relationship connecting C and L, cost and length. The next one says, so it now says we find the cost of painting a room of 9 meters squared. Now, having established this relationship, then it is easier to solve any other question following. It says we find the cost now of painting 9 meters squared. So our length has now been changed. Length has now been changed to 9 meters. Therefore, C being the subject of the formula already, we have our C equal to 20 by 9 squared. So which means that 20 by 81. So 81, that is 810, 162 by 2, then 0. So that is going to be, C is going to be 1,620 naira. So that is going to be the cost. You see how fast we're able to calculate that, because we had initially established this. Alright, we're going to go on to solving number 2. So number 2 says a quantity A is inversely proportional to the square of another quantity B. So we write that as A is inversely proportional to the square of quantity B. So this is the right notation. Then we introduce our constant by saying A will be equal to K over B squared. Alright, so this is what we are going to be working with. Now, it means that we'll be solving for K. K will here be equal to AB squared. Alright, so and A is given to be, so K will be equal to, since A is given to be 800 and B is given to be 0.4. So that we have K equals 800 times B squared, that is 0.4 times 0.4. So that you have, cancel this, you have this, and you move this. 4 times 4 is 16. So 4 times 4 is 16, 16 times 8. So you have K equal to 128. So our constant is 128. So our equation that connects all of this together is going to change to A equals 128 over B squared. So this is our new equation now. So to solve for any other portion, component of that relationship will become easy since we have established our constant. So we have find the constant of variation. Okay, we have found the constant. Now it says find B when A is 512. So A has been given to be 512 and B is unknown. So using this, since A is 512, we just plug that in. We have 512 equals 128 over B squared. So we can cross multiply. We have B squared equals 128 over 512. So from here, we discover that if we divide this by 2, we're going to have 256. Divide this by 2, we're going to have 64. So, and these are both perfect squares. So it means we'll have B squared will be equal to 64 over 256. So you can take square root of both sides, and square is going to cancel square root here. So you're going to take square root of this, you have B equals square root of this is 8, and square root of this is 16. Then 8 takes care of 16, 8 here 1, 8 takes care of 16 twice, so you have B will be equal to 1 plus or minus 1 over 2. Plus or minus 1 over 2 because, of course, we are taking square root. So it's going to be plus, so B here will be equal to plus or minus this, and our answer is going to be plus or minus 1 over 2. Then the second one says A, we should find A. We have to find A when B is 0.2. Using the same equation, we have A equals 128 over 0.2. Now, since it's B squared, it's going to be 0.2 whole squared. So that you have 128 over, now 0.2 is 1 over 5. That is 0.2. So we're going to use that 1 over 5 all squared to make the work easier to solve. So we have 128 over 1 over 25. So that here we have 128 over 1 times 25 over 1. So we're going to be using calculator to resolve this, unless we want to, equal to 128 times 2 is 2560. So 2560 plus 5 times this, 10 equals this, so we have 640 plus 640. So we have 0, 0, 2, 3. So the answer is 3,200, and that is our A value. That is our A value. Alright, here is another set of questions. It says, the first one, number 3, says, if x varies inversely as y, so the same method approach, we'll begin to write our parameters as we're given, we have number 3 says, if y, x, varies inversely as y, and x is 2 over 3. So from here, we know that by introducing constant proportionality, we have x will be equal to k over y. So that our k, in that case, will be what? xy. So x is given to be 2 over 3, where y is given to be 9. So to find k, we have k will be equal to x times y, which will be 2 over 3 times 9. So this takes care of this. So we have k equals 2 times 3, and that will be 6. Alright, so when we introduce the constant into the real equation, we have x equal to 6 over y. And this is the formula connecting x and y. It says to find the value of y when x, so x is given to be 3 over 4, and y is what we are looking for here. So we simply plug our values into the equation. We have x, which is 3 over 4. We have 3 over 4 is equal to 6 over y. So we can easily cross multiply there. So we have 3. When we cross multiply, we have 3y is equal to 4 by 6. So you divide both sides by 3. And then you have 3 here 1, 3 here 2. So that you have y will be equal to 4 by 2, and that is 8. Alright, so that was quite easy. Now the next one, so that was an inverse variation. And this one also looks like inverse variation. It says y varies inversely. So another inverse variation has x cubed, and x varies. Okay, this is a joint variation because y is varying. So let's interpret it. Number 4 says y varies inversely. So y varies inversely as x cubed. So using k as our constant proportionality, we have y will be equal to k over x cubed. And x, so it also further says that x is actually varying directly as z squared. So find the relationship connecting. So we introduce a constant, and let's introduce a separate constant that's different from k, because of course this is a different relationship than this. So the constant that will relate the variables here will be different from the constant that's going to relate the variables here. So we can use another number to represent our constant. So we can say y equal to, we use constant c, k. We usually use c. Now it doesn't mean it's restricted to that, but you can use c as well. So you have cz squared. So in our state, now we should find the relationship between y and z. Okay, so we are supposed to connect this and y and z. Okay, if m is the constant of variation. Okay, if m is the constant of variation between y and z. Alright. Okay, so the next thing we're going to do here is that we can substitute in either case. So let's make this first one our equation 1, and make this one equation 2. So since y is k over x cubed and x itself is actually this, so we can say that y will be equal to k over, since x is this, we simply plug in this value for x. So we have cz squared. That is what we have for x. But of course x is cubed here, everything cubed. So that we now have y will be equal to k over c will carry the cube all alone, dot z will carry 2 by 3, you have 6. So we now have that y will be equal to k over c cubed dot 1 over z raised to power 6. Now remember that both of these are constants. Okay, and we are told to represent that constant by m, since it's saying that the constant of variation between y and z is m. So we'll say that k, since k over c cubed is equal to m, therefore y will be equal to m dot 1 over z raised to power 6. So we have y equal to m over z raised to the power 6. This is the relationship between y and z. So this will be our equation 3. Alright, I'm going to solve other questions as well. Now move on to number 5. Number 5 says the area of a triangle varies directly as the height and directly as the base. So we are going to be using the symbols A, H for height, A for area, of course, and B for the base. So this is a joint variation. So it says the area of a triangle. So we interpret as written there. We say A, area, varies directly as the height and directly as the base. So the same area varies directly as the base. Definitely, we know that A is going to be equal to KHB or KBH as you deem it fit. What is the constant of the variation? If A is 80, A is now given as 80. A is 80 and B 20. So we are asked to find and H is 8. H is 8. Alright. So we are going to, make K the subject of the formula here in order to solve for K. So of course we can solve directly by just plugging in our values. So we have 8, we have A which is now 80 equal to K dot H is now 8 by 20 is, B is 20. So K will be equal to 80 over 8 by 20. So we have 1 over 2. So K equal to 1 over 2. So it now means that this equation will be rewritten here as A equal to, since we know the value of K, we plug that in, equal to half HB, or simply say A equal to HB over 2. So this is the equation driving the relationship. So we can continue further to find H when A is 66 and B is 64, B is 4 rather. So we have H is unknown, A is given to be 66 and B is given to be 64. So we simply plug in our values as we've always done, such that we have A, which is 66, is equal to H, which is our unknown, all over 2, times B, which is 4. So B is 4 and H is 66. Always confirm, cross-check to be sure that those are the values you are given. So we cross-multiply so that we have 4H will be equal to 66 by 2. So you can divide both sides by 4. And when you divide both sides by 4, you have 2 is going to cut 2 here and you have 33. So that H is equal to 33. Alright, we're going to proceed to number 6. Number 6 is a partial variation. Looking at the words used there, it says partly constant. So it says the cost. So we're going to use cost of lunch. The cost, we're going to use cost, C for cost. For a group of players is partly constant and partly varies directly as the number of players, N for numbers of players. If the cost, so we go and interpret down, we say number 6, it says the cost is partly constant and partly varies directly as the number of players, and it also partly varies directly as N. So we have it that N is constant. So if we'll be using our, I love to use the constant A and B. So C is of course constant, so it will be A here. C will be A here because that is partly constant. So by the time we introduce our second constant, C will be directly related to Bn when we introduce our constant here. So we now have overall equation will be equal to C equal to A plus Bn. I'm going to re-explain again. It says that C is partly constant, so I'm using my constants A and B to represent my constants. So I say it is partly constant. And of course, partly varies directly as n. So we introduce the second constant, Bn. So we have this overall equation. Alright, so we're supposed to find the constants first. Now, as you well remember, partial variation is almost always going to lead to simultaneous equation. So if the cost is 400, C is given to be 400 naira, and when the number of players is 20, the number of player is 20, and 600, the same C is now 600 when n is 35. So all we do is plug our values, the given values, into the equation. So we have 400 equals A plus B into bracket 20. So this forms, so we have, if we revise this, it becomes 400 equals A plus B 20B. So this becomes our equation 1, and we plug the next set of values for C and A respectively. So we have 600 equals to A plus B into bracket 35, so that we have 35. So we have 600 equal to A plus 35B, and this becomes equation 2. We can as well rewrite the equations on top of each other. So we have 400 equals A plus 20, this is equation 1, and 600 equals A plus 35B, is equation 2. So here, we can simply use the elimination method, seeing that there is 20B here, seeing that the coefficient of A, one of the unknowns, is actually the same in both equations. So we can use elimination method. So you see here we have positive and positive here, so it means we are going to be using subtraction. We're going to be subtracting equation 2 from equation 1. Let's subtract equation 1 from equation 2. So we subtract equation 1 from equation 2, or you can also subtract equation 2 from equation 1. It will give you the same answer. Okay, for example, let's subtract equation 2 from 1. 400 minus this is going to give us negative 200 equals this minus this is going to be 15b, negative 15b. Because now for the purpose of doubt, let's check if we subtract equation 1 from 2, that is the reverse. We have 600 minus 400, we get 200, which is positive. I'll get 35 from 20 to get 15, which is positive. So this negative is going to cancel negative here, so you see we get the same answer. Alright, so now divide both sides by 15, so that we have 5 is going to go in 15 3 times, and 5 is in 240 times. And of course, our answer is going to be 400 for B, 400 over 3. So we can leave it this way, since it's a constant, which means we are still going to use it to solve for other values. Alright, we can use it to find A now by substituting into one of these two equations the value of B. So we have 40 over 3. 40 over 3. We have 40 over 3. Substitute 40 over 3 for B in equation. You can pick any of the equations that you want to substitute in. I would love to substitute in 1, seeing that it's simpler. We have 400 equals A plus 20B, and that is our equation 1. So it means that anywhere we find B, we are going to substitute this. So we have 400 is equal to A plus 20 by 40 over 3. So here we can multiply through by 3. If we multiply through by 3, multiply through by 3. So we have 400 by 3 equals to 1,200 is equal to 3A plus this by 3 is going to give us the 800 again. So that we have, this is going to come here, so we have 3A, we're going to collect like terms, now. 3 will go to 1,200 minus 800. So we have 3 equals 3a equals this minus this is going to give you 400. So we divide both sides again by 3. When we divide both sides by 3, we're going to have a equals 400 over 3. Now you might be surprised that the reason why I am not modifying my answers it is because these are constants and we're still going to use them to solve for. So we can stop here, leave our answer in this form. We can leave our answer in this form. So we will now find the cost when there are 25 players. So we are expected to find C now when n equals 25. So we've gotten A constant and B constant. So we have, since C, according to the equation, is equal to A plus Bn. Okay, if we were asked to find the equation connecting them, we'll simply substitute these two values of the constants into the equation, so that the equation connecting them is going to be C equals A, which is 400 over 3 plus 40 over 3b over 40 over 3n, so that we can multiply through by 3, so that we have 3c is equal to 400 plus 40n, so that c would definitely be equal to what? 400 plus, of course, you can leave the answer this way or say 400 from here, c will be equal to 400 plus 40n over 3, all over 3. It is the same. It is the same. All right. But since we are not asked to find the equation connecting them, all of this will be useless. So we are going to plug in our values now, since we are given the value of n. So we have c equal to a is 400 over 3 plus b is 40 over 3 n. Alright, so seeing that, okay, n now is given to be 25, so we have times 25. So we can go on to say that c will be equal to, 400 plus 40 by 25 all over 3. So that we have 3c is equal to 400 plus 400 plus 25 is going to be 1000, so that we have 3c equal to 1400. So we have divided both sides by 3, so that c will be equal to, when we divide both sides here, we're going to have 4, 2, and in 200 is going to be 6 and 6.67. Alright, so this is going to be the answer for C. This is going to be the answer for C. Alright, we're going to go over to number 7. Alright, lastly, we are going to be taking this question. It says that the time taken to sink a well varies partly as the depth. So we're going to use the heuristic method. We're going to answer the question. So we have, it says that the time varies partly as depth. So since it's varying partly as depth, we're going to select our constant. Now, if you look at this equation very well, remember the almighty formula that you have x will be equal to, minus b plus minus root b squared minus 4ac over 2a. So the only condition for, so you see they look alike. So remember, this equation is getting from ax squared plus bx plus c. So since it's gotten from this, it means that we are going to transform our equation to something like this. Our equation to something like this. So t is representing the c here. If you look at it here, this is where it appears here. So, and that is where c appears there. So it means that if we equate this to 0, we're going to have ax squared plus bx equals minus c. That is, we take the constant to that side. Alright. So it means that our constants will be a, and we take c to that side. Our constants will be a and b. So in this case, b is n. B is n. So, and c, and a rather, is k. I hope we got that. So our n is the same as the b here, and of course our k is the same as the a here if you look at it very closely. So from here, we already know what to do. So it means that our first constant is going to be n, and our second constant is going to be k, of course. So n and k are the both constants that were used in the question. So you have, it says that it is partial constant, so we can directly write it as, since it's partial variation, you have it that t will be equal to partly, varies partly, okay, partly as the depth. So it will be nd, since the first constant is n, I said that, and plus partly as the square of the depth. So the square of the depth is going to be kd squared. So the first constant is n, and the second constant is k. So this becomes our equation. So that by the time we want to solve this in quadratic equation, the equation becomes kd squared plus nd. Now, t is going to come here, minus t is equal to 0. So, and if you use the completing squares method, you are going to end up with this. So that this will become our a, b, and c. So if we relate that into that equation, then it means that t will be equal to, no, d will be equal to minus n, here minus b. So it's going to be minus n, because it's minus b here, so it's going to be minus n, which is this place here, minus n plus or minus root n squared. Now, because it is, okay, so we have plus 4a, which is k, t, which is minus t now, all over 2 times k. So we have d will be equal to minus n plus or minus root n, now n squared, now, no, it's supposed to be minus 4ac, minus 4kt, so that minus will multiply minus to give us 4kt all over 2t. This is the best way to prove it. This is the easiest way to prove it. Now, of course, you can go through the process of completing squares. You are still going to arrive at this answer. All right, thank you very much for sticking with us till the end of this video. I really hope that you have been imparted from the what we have done so far. Please do well to leave us a thumbs up for the video, and also subscribe to the channel, because we post contents that help you to understand mathematics and science generally. Thank you very much.